Okay, so even answers, this is 5.8 B, maybe? I don't know. It's 5.8. Here, even answers, pause the video, check your work, and then we're going to see what questions we have. 32 says, does a cubic function always, sometimes, or never have a turning point? So, cubic function. What's your most basic or the parent function for a cubic function? X to the third, because it's x cubed, that's it. Like nothing else is happening to it. It doesn't have a 2 in the front of it, and doesn't have a minus anything anywhere. I'm going to graph it on this calculator so it'll be big. Not too small, not too big. Goldilocks. Okay, so x cubed, x to the third power. This is the parent function. Does it have a min or max? It's hard to see because it's so straight here. And when we get to calculus, we're going to talk specifically about what this looks like. But if you can imagine for me half of the graph on this side, and then this being the middle, and then half on the other side. This half looks like half a parabola, right? It looks like concave down. Remember when we described that when we were playing that parabola game? Okay, and then this side looks concave up. It has a change of concavity at 0, which is a huge calculus thing. This is from this chart up here. This is the second derivative, all big words that you don't know, but you can see that the half and then the other half. This point is not the highest point of the points around it. If I looked at it on a piece of paper and tried to draw stuff, if I said in a neighborhood of points, this point is higher than all of these points, right? But over here, it starts to go bigger. It's smaller than all of these points. So it's not a min or a max. It doesn't go up and then back down. I have to have that to be maximum. And it's also not a minimum for the same reasons. It's lower than all of these points, but it's higher than all these points. So this is an example of one where it doesn't have turning points. It doesn't have a minimum or maximum on the function going forever in either direction. If you stop the function, if you stopped it right here, you'd say this is the maximum. But generally speaking, it goes on forever, so it doesn't have that characteristic. However, I can also draw a cubic, which you probably drew some in your work, and I could make up something, but it would probably have some x squared in it. I can play with them, but you know a cubic can also look like this, and then it would have 2 turning points, which is 1 less than the 3 up here. I don't know what this is, but it looks like this, where it has 2 turning points. So sometimes it has turning points. Here it is. And this one doesn't. So it's not never because I can have it. And it's not always because here's a disqualifying graph for always. This is not always. This is sometimes. It's definitely not never because I have this one. So is that better? Okay. So this is the counterexample of the parent function. Okay, and then 34. 34 says, graph the function, then identify its domain and range. Okay, so let's think about this in terms of our polynomial project for just a sec. 34. It's in factored form, right? X times x minus 3 squared. That's 2. You can't tell it, but I'll make it better. It's supposed to be squared. So none of you have this sort of thing for your polynomial project because you don't have any repeating factors or zeros. But this one does, and this was in the video lessons that we did, so we haven't done this live, so I sort of a little bit feel like we haven't done this together. But how many zeros does this have? Trick question. It has 2 and 3. It has 3, but 2 of them repeat. So there's 2 different values, but we count it as 3 because this is really a cubic function. So this has a degree of 3. So it must have 3 zeros. That's the fundamental theorem of algebra. And one of them is 0. And the other one is positive 3. But 3 has a multiplicity of 2. Which means what when we graph it? It's like a bumble. Bumbles bounce. Who knows what that's from? Seriously? Clarice, Bumble's Bounce. The what? Silence of the Lambs. But Clarice, isn't that her name? No, but okay, so I did, but there's no. He's supposed to be an abominable snowman. How do you spell abominable? He's a bumble. Bumble's Bounce. Beep. Who? What's it from? Rudolph. There you go. Wasn't her name Clarice? Okay. So we went dark, but we came back to Christmas and Bumble's Bounce. If I gave you Rudolph, it would have been a kind of a dead giveaway. I was trying to help you out. I could have said the dentist. Well, I didn't give you Silence of the Lambs. In my head, it wasn't there. I was gonna rewind this and delete it, but they told me that Bumble's bouncing is funny. I know you can't hear them, but we had a whole discussion about bouncing. Anyway, Bumble's Bounce. This is from Rudolph the Red-Nosed Reindeer. So at 3, it bounces. It has in behavior of 1, 2, 3. There's a 0 here and a 0 here. These are zeros. And it has up and down behavior because it's degree 3. Right? Saturday Night Fever for you is this way. Therefore, we have to get from here to here. How do we do it? We bounce at 3. So we come to 3, we bounce, and then we come back down to 0.
If it's even, it's
yes, if it's even, it's no. Okay, this degree is 3. If you multiplied it all out, it would be a 3rd degree polynomial, which is odd. Odd has Saturday Night Fever. This little even guy represents this 1, 0, and it bounces at that 1, 0. Better? Yeah. Okay, so this is 34. What else did they want us to do? Graph the function, identify its domain and range. Well, if it's Saturday Night Fever, then its domain and range is everything because it goes up forever and down forever. And there's no, how many ways can you break a function? What's the domain breakers? Do you remember? Sure you do. What can you not have in math? What's not allowed? -0 is what they put on the weather when they think it's cold, and they post that -0. They're crazy, I know. What else? You can't, -0 is not really a thing. That means you're approaching 0 from the lower values. You can't have 0 in the denominator. No. Okay, you're not allowed to have 0 in the denominator. You're not allowed to. Because I can't have 1 if I don't have any. Number 2, you can't have, as far as graphing things, we made up a mathematical thing, a system to work with it, but you can't have the square root of negative numbers. So that's not allowed. Okay, so those 2 things are the domain breakers. Do I have any square roots in here? No. Do I have any fractions in here? No. So the domain is all real numbers. There's nothing I could put in that would break it. Okay, so domain is everything for polynomials. And when you see the end behavior, it goes up forever or it goes down forever. It's also got a range of all real numbers. So here was where I put domain and range was all real numbers. If it had been a 4th degree like this, then this would have been the lowest y value, whatever it is. So it would have a restricted range, but the domain would still be all real numbers. But y'all didn't ask me about any of these yet. Just abominable snowman, whichever how you say that. He doesn't like that. He has teeth that look like this, remember? And big eyes.
Isn't he like a bear?
He just doesn't have 3, I don't know.
Not like 3 snowballs.
Let's pretend for a minute that I have these 3 zeros, which I don't think anybody has. Because not many people had more than 6 because we rolled a die, but there were some people who chose other numbers. So anyway, it's very improbable that anybody has this. So I don't know what order they go in, but this is what I know. I asked you for this. Can you do this? Okay, B. Then I could write the polynomial as x plus 7 times 7x, oops, I lie, 2x minus 7, because that would be positive 7 over 2, there you go, and x minus 5. I could write it this way. What form is this? Factored form. And probably because this is a project, maybe I want to label that as factored form, because that tells everybody I know what it is I'm talking about. I could label these as zeros or x-intercepts, like, it makes sense out of what I'm saying. But it's a project, so I probably don't, shorten that to int. Anyway, then I could say, well, p of x is a polynomial if I multiply it out, which I'm going to multiply this one last because that's what I do. X squared plus 2x minus 35 times 2x minus 7. So I multiplied these two together and got this, and then I'm going to multiply by 2x minus 7 and get what that is. So y'all did this in your Zoom, and you're supposed to check each other's work, and I feel like a couple of you figured out what you were doing at this point, and you had your stuff checked. So if I was doing this one, I would say that's 2x cubed minus 7x squared plus 4x squared minus 14x minus 70x plus, I had to choose big numbers, didn't I? What's that? 35, 3, 245? And if y'all were in my Zoom with me, you'd surely check that and make sure it was right. 2x cubed. We'll find out in a second because I'm going to do synthetic division and confirm it. So this represents p of x in what form?
No.
Okay, also? So it is a polynomial here. It's not a quadratic. It's definitely not a trinomial. It's a cubic, and it's a 4-term one. It's not a trinomial. I haven't asked for that. If you want to include that, sure, include that. But don't give me wrong information. That would be bad. So factored form is important to know because that tells us factors. Polynomial form is important because we can see the degree right there, and we can tell about the terms. And we use this one for synthetic division. So what did I do next in my polynomial project? To do why? Why did we do it? To check them. So I pick all of these, -7, -7, and see if it works. Into 2, -3, -84, 245. So that'll be 2, -14, -17. 17 times 7, 9. 119? Is okay, I'm really bad at multiplication, addition, subtraction. I can do lots of good stuff, and I teach math. I know, but I in my head it's full. So I rely on you to do the computations. 9 minus 4 is 5. 11 minus 8 is 3. 35? Yeah. Excellent. Is it positive or negative? Positive. Okay, go. 7 times 35. Already did that. 245. And it's -0. Hallelujah. It worked. So -7 works. And I've just checked it. And then I checked my other two guys, and they work, and I've confirmed that. So that's what you were trying to confirm in your Zoom, that all that made sense. Are we all on the same page? Yes. Okay, so I would write this pretty for my project, not like this. This is my rough draft because I'm doing this in 5 minutes. And then I go and I graph it like this. 12 minus 7. 1, 2, 3, 4, 5, 6, 7. Boom. 7 halves. What's that? Like 3 1/2? 1, 2, 3 1/2. Oops. Doesn't go there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 1/2. It's positive. And then 5 here. My end behavior, so I talk about that because it asked me to in my stuff. Like I write down everything. You write down everything I've asked you to write down. So the end behavior, we're going to say it's degree 3, 3rd degree. We're not really going to say Saturday Night Fever. I mean, you can throw that in there. It's not wrong. What we're going to say is x goes to infinity. What does a 3rd degree polynomial do in the end behavior? y goes to infinity. So these go together, and then as x goes to negative infinity, y goes to negative infinity. So this goes up and this goes down, and I've written it out in math. It asked me to do that somewhere. I figure out a place to write it. It's your project. Make it pretty. Put it where you want it. And then I go through all these zeros, and I know in my rough draft that it kind of looks like this, but I don't know exactly how high or low it goes. So what did I say to do to estimate this maximum point?
You go from between the two zeros.
So just the way I've drawn it now, it seems logical it might be at -3, right? So I don't. So I'm going to guess it's probably somewhere around -3. I'm going to estimate it. It says in your list, estimate it. So we're going to say we estimate x equals -3 is the value of the maximum. And then we go -3 into synthetic division, 2, -3, -84, 245, because we already know that this synthetic substitution will tell me whatever the remainder is the y value. So here we go, 2, -6, -9, +27. Subtract, what you need? -9, 27. Somebody subtract that. 7, 7, 7 minus 2 is 5. Okay, -57 times 3. No, 21, 2, 15. So 17. 171. And it's positive. So that's 300, 416. Okay, wow. So maybe I need to not put 100, 400 tick marks, okay? Maybe I need to go 100, 200. You know what I mean? Like, maybe my scales are not the same on the x and y axis. Sure. I mean, you could make it big, but yeah, you're not going to count to 400. But you could totally, okay, nobody picked numbers this big. That's why my graph is so big. But you may have it still be a big number. So you would do the same thing here. I would guess between 3.5 and 5. Maybe I just want to try 4. Okay, 4's in the middle. I don't need to go 4.12567 or anything. I just could try 4 and estimate that one and get the estimate. Are you with me? How I'm estimating? Does that make sense? Okay, you can't see it, but there it is. You would estimate 4 for this one, and it should be a negative number, and it would give you this estimate. It doesn't say what is the maximum like a calculator exercise. This is what you can do in your head, and you can do all of this, even these little asides where you do math in your head, and estimate these. There's one more place that it doesn't say specifically on your list that you could estimate. What would be another good point to do that's so easy? The 0 right here, like x equals 0. So you could also find the y-intercept, because that is this equation right here. So it's at 245, so it should have been here on my little graph, okay? Because all you do is put 0 in. That's so easy. 0, 0, 0. Ooh, boom, 245. So the y-intercept would be handy, 0, 245. Okay? So the idea is that we worked a little bit at a time, and you did a great job of doing this with us in blue, because this was a project and I asked you to do stuff and you didn't really know what I was doing. But now that we've covered all these sections, all of these details make sense, I hope. Yes?
Yes.
Okay, so we found the zeros, we found how to put them into factored form. Polynomial form was multiplying it out. We understand synthetic division. We understand that if we get 0, it is a factor. And if we don't get 0, this is a point, okay? So at the end of this, maybe I should say -3, 416 is a point. And I don't want to do a complete XY chart. I don't want to be doing 1 and whatever hundreds of point that is. But this is a great point to give me shape. And once I know what that is, then I can draw my real one on my real piece of paper that I figure out. And I write out all this stuff in math so that somebody who's never seen it goes, oh, that's what synthetic division does. Or, oh, factored form. Like, You want to label stuff. This is a project. Make it pretty. Label all your stuff. Is there anything I haven't covered? Here's my list of everything. When you're turning in your completed sketch, I want your completed sketch like, oh, the people at home lost it this time. I mean, the people in the classroom. Those of you at home, you can see this pretty picture. Hold on. So on your project, and you can number it, or you can just make sure that you've covered all of those numbers. I want to see this because I can see this to there. That's pretty simple. I want to see the multiplication. Like, I want to see this written pretty. I don't want you to just write out the polynomial right here. I want to see the math. This is me looking at all the good stuff you can do. So not just answers, the actual work is important here. All of the synthetic division. So not just this one, but the other two. Then, now that you have all this information, you can make a sketch that makes sense, and you can make it even better with a minimum and a maximum. And the y-intercept. This value? I said, why don't I just try like 4? Because this was 3.5 and this is 5. So I would have done 4 and found out it's the answer, but I didn't find it because this is not real. But you would do it the same way. So this is finding an estimate of the max. It's not the max, okay? You could put it in your calculator and find the max. But I'm really looking for what you can do. What makes sense. And it's just an estimate, okay? We're just trying to make our sketch a better sketch. And then, so we try 4, and whatever answer we get here is the y value. So it would make a point for remainder.
Okay.
Because that remainder is what you would get if you substituted it in. If you didn't want to do synthetic division here, you could go back up here and say P of 4 and plug in 4 here. 4 cubed, 4 squared, 4, and figure it out. It doesn't have to be synthetic substitution. You could do regular math substitution. That's perfectly fine. But show me how you got those min-max values. The people who tell me their maximum value is, what did I say, 3? -3, and then 432, oopsies. I don't know why there's a decimal there. 432.5. I'm just going to, say I doubt it. I think you used a calculator. I really want you to just estimate it, okay? Because we're sketching and showing what we can do sketch-wise. Okay. So if you give me the actual maximum, I'm going to wonder what happened. Because this is so easy. Just do this. Okay. Any other questions? So this project is due next Thursday because I wasn't here. Y'all weren't here. So Thursday means that if you've done it and you feel good about it, you can leave it with me. If you want to rework it a little bit or make it colorful or, I don't know, it's a project. It should look decent. Then that gives you this weekend and the week to do it. I don't know what other stuff you have on your agenda, and I wasn't here, so I feel like I should just make it due next Thursday. Okay? So you can bring it any time that it's done. That would be perfectly fine. Polynomial project. Questions? Any more questions? This is the distance learning assignment, and it should be posted on Google Classroom. Okay, in the video. Bye.